Hello, I'm Young-Shin from Media Communication Lab at Korean University. I'm here to present our work moving window regression, a novel approach to ordinal regression. In our work, we aim to estimate the rank of an object instance precisely. For example, we predict the age, shooting decade, or aesthetic score of an instance. However, direct rank estimation is difficult because there is no clear distinction between ranks. For example, in facial age estimation, there are no clear aging characteristics in each age class due to large individual aging process differences. To deal with this issue, auto learning attempted to do the relative assessment. It is easier than absolute assessment. Specifically, if there are two photos, A and B, auto learning predict order relations such as A is older, similar, or younger than B based on the ternary classification. We extend classification-based order learning to regression-based one. We regress a relative position called row rank between two references. This regression is performed iteratively with a moving window to estimate the input rank. First, let me introduce the row rank. It measures how much greater the input is than the first reference and how much smaller it is than the second one. If the row rank is close to -1, the rank of input is close to that of the first reference. If the row rank is close to 1, the rank of input is close to that of the second reference. For example, if the input is 2 years older than the first reference and 8 years younger than the second reference, the row rank is -0.6. To predict the row rank, the row regressor is designed. We estimate the absolute rank of input by moving a window and predicting the row rank using the row regressor. This MWR process is performed iteratively with 4 steps. Step 1. To make an initial prediction, k nearest neighbors of input are found. Step 2. We set a search window based on the previous estimate. Step 3. We regress the row rank within the search window. Step 4. We repeat Step 2 and Step 3 until convergence. In rank estimation, each rank group has different characteristics. To deal with this issue, we employ global and local row regressors. The global row regressor captures patterns from the entire rank range. The local row regressors only exploit the patterns in the specific rank range. We estimate the rank of instance globally and then locally. MWR provides the state-of-the-art performances on Move2 and FGNet, which are representative facial age estimation datasets. Figure shows the success cases in facial age estimation. For each image, the ground truths are provided with the absolute error within the parentheses. Codes are available at the following link. Thank you for listening and please visit us at poster number 9B.